Hello and welcome to this repair tutorial, and today we're going to look at a Samson Servo 200 audio power amplifier. So just before we sort of get into the technical specifications, just to sort of make the point that when we talk about power amplifier, and I do appreciate maybe for some of the listeners, it's very easy of course to associate a power amplifier and say, well, actually when you look at the specifications for this amplifier, which delivers 200 watts in what we term bridge mode into an 8-ohm speaker load, you may regard that not really as a power amplifier. But when I'm referring to a power amplifier, I'm more associated with the actual design construction of the amplifier, and these types of amplifiers are different in terms of design than what you would compare if it was a traditional hi-fi amplifier for domestic purposes. But I do accept that within the marketplace, as with all audio equipment, you'll have an entry-level specification, then midpoint, and then high end. And then typically when you look at the higher end power amplifiers, you know, yes, normally in terms of kilowatts of output of power, you know, very, very large units, which would be used for venues and stage work. So just that sort of clarification there. So in terms of when this amplifier was released, it's about circa 2005. And when you look at the design, cosmetically, it is quite an attractive power amplifier. You know, I've sort of worked on and seen many amplifiers, and some are just like a big sort of metal case, and there's just not really sort of any sort of design gone into the really the look of the amplifier itself. So the amplifier is what we call 2U size, and it could be mounted into a 19-inch rack. But that normally is associated maybe for studio work, or maybe if it's in a fixed venue. You can also put it into what we term as a flight case, and that's very common for audio amplifier, power amplifiers that are used for mobile work. So the DJ, as I'd refer, would mount this into a flight case, and then on the front you would unclip, you know, the protective cover, and then at the rear you'd be able to make your necessary connections. I've sort of mentioned this previously on other audio tutorials. Power amplifiers do tend to have quite a tough life. They don't tend to arrive in the workshop for any sort of service work or remedial work until there's a physical fault that happens with the amp. And then when they're stored maybe into a rack, or they're in some form of flight case, sometimes the ventilation which these amplifiers require is not met, and you can find that the amplifiers do overheat, and that could also lead to premature failure. The other point, and I've sort of put the link in the description for the video, the owners or the representatives for Samson Audio has changed, and in more recent months what you find is that the company is very, very responsive. So if you are looking to maybe source the service manual or schematic for the amplifier, if you can't find it online, you can reach out, and their customer service is very, very good, and they will provide the amplifier schematics. I know for the Samson Servo 120 series, that was really a very difficult service manual or schematic to obtain, and there were two versions, one which used conventional semiconductor transistor output, and then the latter version then used these integrated circuits, and that service schematic really could never be obtained, but it is readily available now. So in terms of specifications, and we'll sort of elaborate on this in a moment, the power output is 66 watts per channel, and that delivers then into an 8-ohm speaker load. If you then connect a 4-ohm speaker load, then that will increase then to 100 watts. And then from the rear, when you look, you have a selection switch. So you can select between stereo mode. It doesn't support what we term as parallel, but you can switch between stereo and bridge mode. So just for a sort of clarification on what this bridge mode actually means, and you can find bridge mode on many power amplifiers, but you can also find them in some cases on more powerful hi-fi type amplifiers. So what happens is, and commonly this mode is also referred to mono bridge mode, what happens is that you would have a single input connection on the rear, and in this case for this amplifier it would be on the left input channel, or channel 1, and then when the bridge mode is selected, internally what will happen is that the two output modules, or the two output stages, then will deliver power output into a single speaker connection. But unlike when you connect in stereo mode, you're not connecting to the plus terminal and the negative terminal for the speaker. What happens in the bridge mode is you're just going positive to positive of the speaker, but then the negative then connects then to the positive terminal on the other power amplifier stage. So to sort of what happens here is that you get the combination then. And what's important is that when you're in bridge mode, typically you're looking at an increase of about 3 times power output. So 66 watts in this case takes you, just over, and then you reach this 200 watt mark into 8 ohms. Often with amplifiers and power amplifiers, when you read the technical specification, sometimes they can be kind of a little bit misleading. It's the devil in the detail. So when I look at this amplifier and I say, okay, it's a 200 watt amplifier into 8 ohms, that is true, but only when it's in bridge mode. It's not when it's in conventional stereo mode. And then what you'll find is that the output then is out of phase by 180 degrees, effectively driving the speaker cone both plus and then minus with respect to the audio signal, and then that gives you that increased range rather than you just being limited by the single channel output with then reference then to the ground. And then frequency response is 10 Hertz to 55 kilohertz, and then total harmonic distortion comes in at 0.1%. And the amplifier is classic here. It's running in AB mode. This is not an amplifier, for example, that runs in Class D mode. This is conventional Class A, Class B. And then for the input sensitivity, we're looking at 1.24 volts maximum. And then common with these types of amplifiers, you have 2 types of input connection, which will be balanced and unbalanced. And I'll sort of remark on that in a moment. And then input impedance for the unbalanced input is 15 kiloohms. And then if your input connection then will be balanced, then you're looking at 30 kiloohms. So let me just sort of touch on this and just sort of explain the difference between the two. When we talk about something being unbalanced, if you look at the connector, and maybe you're connecting to a musical instrument, it could be a guitar, it's not uncommon that these devices support an unbalanced connection. So when you look at the connector, in this case it's the RCA connection on the rear, what you have is you have a positive conductor, and then you will then have a negative, which is actually the screen or the ground connection. So there's really only 2 connections that are made in terms for the unbalanced. And the reason for that is that these connections are limited in terms of the amount of cable length. So the cable length may be sort of 10 or 15 feet, and that is fine for an unbalanced connection. Because what we understand is if you take a piece of wire, then that piece of wire will always act as an antenna. So over a relatively short distance, of course, there will be some degree of electromagnetic interference which comes through to the cable, and then the screen connection to some point would try and limit that and ground it, but there will be some electrical noise which will be transferred then onto the positive signal connection, and then that noise would then enter into the amplifier. But really over that sort of cable length it would be quite minimal. But what we understand is that maybe if you're connecting a mixer or you're connecting other equipment, normally those types of equipment support what we call balanced. And what that refers to now is that actually you have 3 connections and more commonly 4 connections. So what am I referring to there? Well, for the audio signal you have 2 positive conductors. So you will have a signal which will then come in on the one conductor, and then you will have another signal which will then come in, which will be out of phase by 180 degrees. Now the reason why we do this is when these devices are connected, often the cable length is very, very much longer than what would be used for an unbalanced connection. So what you need to do here is you need to use a different type of approach in order to eliminate the noise. So when I talk about the 3 or commonly 4 connections, what happens there is that you have the 2 positive conductors, you will then have a ground, and then often you will have a screen as well. So if for whatever reason electrical noise then enters into the through the cable and then comes then onto the conductors, that electrical noise of course will be passing them through into the amplifier, but of course it will be out of phase by 180 degrees. So when it comes into there, what will happen is that the signal then will be realigned, and then any electrical noise then will effectively be cancelled out or will become an absolute minimum. So when you look from the rear and we talk about balanced and unbalanced, that's what we mean. For short cable lengths, and if the device being connected supports unbalanced, then you would just have the two connectors or two single conductor and then a ground. And then if it's the balanced, typically we use these for much longer runs, very common in studio applications where you're connecting mixers, for example, and then you would have 3 connections, so 2 cores for the audio signal, then a ground, and then an overall screen. And then the purpose for that is the out of phase and then realign back inside for the amplifier to eliminate electrical noise. And then most power amplifiers will support input clipping, and that just prevents you then from overdriving the amplifier. And this amplifier has a 24 volt DC fan, and I'll show this a little bit later on in the video, and it's a variable speed fan. Some amplifiers that are used in studio work would not have an internal cooling fan, because when you're in a closed environment, the last thing you want is maybe the noise from a fan being used, to cool the amplifier. And there's many amplifiers out there which don't have internal cooling fans. For this amplifier it does, but what I would say, the noise generated from the cooling fan is really insignificant. You don't actually hear it. And then again, commonly with these amplifiers you will have multiple protection modes. So the first one is that you have the short circuit protection on the rear speaker terminals, but because it's a power amplifier you will also have a thermal cutout as well. So it will monitor the heat on the heatsink for the power output stage, and if for example that temperature rises too high, then the thermal protection will then come in and then protect the amplifier. On startup, because again with power amplifiers often you have a larger toroidal transformer, but some or not many now are more so switch mode type power supplies, you will always have inrush current protection. So it depends what they sort of do for that. It could be a varistor, for example, that is used. And then when you look from the front fascia of the amplifier, you can see here that there is a blue circle around the power button, and when you look from the back there's a series of LEDs that form that illumination. Now when the amplifier is operating normally, that should be blue, but if the amplifier goes into protection mode, then what you'll find is that LED then will then change to orange. So it's a little bit similar to the bearing type amplifiers. And then what you have here are the VU meters, which indicate the audio signal level for each channel, and you have the 2 adjustments then, to set channel 1, channel 2, or input 1, input 2, or the left or the right channel, depending on whichever sort of terminology you want to use to refer to that. And then in terms of weight, it comes at 6.82 kilograms. It is a full metal chassis, which is nice to see, very robust design. And then overall dimensions for height it's 89 millimeters 2U, and then for width it's 483, and then 297 then for depth. Now, what was the issue when the amplifier came into the workshop? Well, this amplifier, as does the other Samson series amplifiers, has a particular issue, and it's associated with the speaker protection relay. And what the customer will advise you is that it appears that the amplifier is in protection mode. When they connect to it, they don't have any audio output, and it doesn't matter if they select stereo mode or they select bridge mode. So what I'm showing next is just an extract from the Samson Servo power supply circuit schematic, because it's actually the power supply board is where this relay is mounted. And then the actual relay brand is a brand called Dongwu, Chinese brand, and it's a 12 volt coil double pole changeover relay. Now, as you can see that I've indicated here, the most common cause is that relay coil goes open circuit. So the relay cannot change over, so hence there's no connection then to the speakers. Or if it doesn't go open circuit, and again I show this in the video, it just goes in the order of megohms. So I think for this it went up to about 4+ megohms. So of course no current could flow through the coil because of the extremely high resistance, and subsequently the relay, couldn't change over. But this same brand of relay you will find in many amplifiers. So this isn't a case that it's just because it's a Samson Servo. No, it isn't. It's because that brand of relay is fitted. So if you see this type of brand of relay in any kind of amplifier, my advice is just to remove it. Even if it's still working, you will find a point in time that the relay then will fail. And then you can see on this circuit schematic there is actually a small timing circuit, and you can see that the delay for the speaker protection relay changeover is set at 3.75 seconds, or effectively 4 seconds. And what they're using there is just an RC network to effectively charge the capacitor, and then once the capacitor then reaches its required voltage charge, which is normally in 5 time constants, it will then energize Q25 transistor, will turn it on. And then the arrangement that you see there, where you have Q25 and then Q26, this arrangement is what we call a Darlington arrangement. So it simply means that it can drive a higher amount of current, and then that in turn will then turn on the speaker relay. So really a straightforward repair with regard to the fault, but trying to get access to this area of the circuit board is not the most easiest, I'll tell you that. So when you try and strip down the amplifier, the first thing is you've got to remove a high number of screws on the top plate. And then once that's done, you've really got to approach how you want to do this. You could release the toroidal fixing bolt for the power transformer and just lift it up, and then that would allow you then to remove approximately 5 fixing screws for the power supply stroke relay protection board, and then lift it up if you wish. But what you will need to do is disconnect the board from the rear speaker terminals. And what I will tell you is, before you even attempt to unscrew the fixing screws for the power supply, you must disconnect it from the audio output power module. And the reason why I'm telling you that is, if you go in there with maybe a screwdriver which hasn't got an insulated shaft, there are resistors which are uninsulated in terms of there's no covering on the leads, and it's very, very easy then for you to accidentally short that down to ground through the screw, and you'll either blow tracks off the board for the power supply because of excess current consumption, or you may even damage the power output module. So there's a multi-pin connector which connects from the power supply. Absolutely disconnect that before you even attempt to remove the board. So for this amplifier, I didn't choose to remove the or to release the toroidal fixing bolt. What I did was I just came in from the rear of the amplifier, and then what I do is I just remove the fixing screws for the different input sockets, and then at the side you will see that there are fixing screws for the left and right panels, and then fixing screws at the rear. What I'm able to do then is to lift the back plate out of the way, and then I could then remove the fixing screws for the power supply board and then raise it up, and I'm showing that in the video then. What you'll find is that some of these amplifiers, and this one in particular, uses lead-free solder. So you'll need to have your soldering iron hotter than maybe a 60-40 lead solder, because it has a higher melting point. And then once the relay had been desoldered, I could then install the new one. But this amplifier also had some bonding glue that had been used during manufacture, so I had to take some time just to sort of get that out of there. It's not the same kind of glue that goes conductive. This is a more recent amplifier, but it was kind of difficult to get the replacement relay in there. There was just really not allowing for any kind of room. So once the relay was installed and then the power board stroke relay board refitted, a quick test confirmed that yes, the speaker protection relay changed over, and that was fine. But this amplifier, from the look of it, looked as if it had been maybe in storage, and probably the environment was probably not the best. So what I'm now showing is the volume control potentiometers. Now these volume control potentiometers are an audio type, okay, so that means that it's a logarithmic type scale. When you operated them, they were just noisy. I don't mean electrically noisy. I mean these are what we call 41 dent, So as you rotate them, they click as they go around, and they were just really badly worn. So instead of you getting like that smooth kind of action as you're clicking to increase and decrease the volume, what you found was it was just really noisy and it just felt rough. So rather than attempt to repair the existing user controls or potentiometers, what I've done then is I've just removed them, and then I've replaced them then with F10K volume control potentiometers. So really the spec here would be F10K single gang, because there's only one carbon track, and then it would have what we term as a D shaft, and these are the potentiometers that were mounted in. And it's quite easy to get access to them as well. You just remove the fixing screws from the front fascia, the bottom fixing screws to the base plate, and then when you look from the rear, you'll have 4 screws left and right, which is for, it's almost like a metal cage, and then one top and then right and then bottom left. Once you've removed them, it's a very easy task then just to get access to the volume control circuit board, which also has the VU meters on, and then you can desolder them. What I would always advise as well, because there are locking nuts and washers which hold the volume control board to the metal cage, whatever you do, don't sort of try and remove the plastic knobs from the front, maybe with a screwdriver or something like that, trying to prise behind. You're not going to be able to do that, and you will damage the fascia. So what you're best to do then is gain access then from the rear, and then you'll be able to release the fixing nut and washer, and then when you pull, then the plastic knobs will just come away, and then there will be no kind of damage then. And then in terms of the next step, what I'm showing now is the cooling fan, and because the amplifier had been in storage for quite a while, it was just dusty and dirty, no more than that. Remember, this is a brushless DC fan, and it was just a case of just removing the 4 fixing screws from the heatsink and then blowing that out then with compressed air line. And then what I've done is I've just took a small brush, just clean out any dust, so the heatsink is completely clean, and then just made sure that the fan, you know, was free running operation. It wasn't noisy in any way, and it was working well then. And then really that sort of, you know, that's all the work that you need to do. You know, you of course you would make a DC offset measurement from the rear terminals, but you know, if there was a major issue with DC offset, what you would find is that the amplifier would go into protection mode anyway. So it was more so just as a functional test and just to verify that the amplifier was working, but because of the nature of the fault and what was required to replace the relay and then the 2 volume control potentiometers, it wasn't like a repair where maybe you'd worked, you know, done extensive repair work, replaced multiple components in maybe the power output stage, and it required a higher level of testing. Not in this case. So there you have it. So really that sort of brings us to the end of this repair tutorial, and I thank you for listening. And as always, if you have any questions or you need any help or support, by all means email Audio Amplifier Servicing at AOL.com, and I'll be more than happy to come back to you and provide any assistance or guidance you may require. So all the best. Until the next time, cheers. Bye-bye.